Welcome to my video. In this video we're going to look at variables and constants for programming with AQA's GCSE in computer science. Let's take a look at what a variable is. A variable is the name of a location in memory that can store a value. The contents of a variable can change or be overwritten numerous times depending on the job of the program. Let's take a look at a real world scenario that you may have seen and not realised uses variables. If ever you've been on the motorway, you will have seen this sign, variable speed limit. And this means that the speed limit can be changed. So why would you want to change the speed limit on a motorway? Well, it depends upon the amount of traffic that's on the road or whether or not there's an instance ahead and we need people to slow down. So let's have a look at how that might work. So you might assign the variable value for speed as 20 miles an hour. And this might be because basically there's a lot of cars on the road. Okay, so we want cars to go slower to avoid an accident. If the conditions of the road were to improve, so maybe better weather conditions or maybe less cars, we might want to reassign the variable value to 40 so the cars can travel faster and potentially reach their destination at a slightly quicker speed but still safely. If the conditions were to improve even further, so maybe it was a day where there wasn't particularly a lot of traffic on the road, so it goes like this, we might want to reassign the variable again to 70. So there's that option to continually keep reassigning the value of the variable depending on what the program's needs are. Okay? Let's look a little bit deeper into how variables work then. Now I said that a variable is a location stored in memory. So what do I actually mean by that? Let's have a look. So let's take a look at these. We've got the CPU, which is our central processing unit, and we've got our RAM, which is random access memory. So the CPU's job is basically to execute instructions and use data to do that, to complete a task of some sort, okay, or run a program. So the RAM is basically to store those instructions or that data. So how do they interact? Well, they interact via three buses, but I've got two of them shown here. We've got the address bus and we've got the data bus shown here, and then the third one is the control bus. Okay. However, there is a more in-depth model of this called the von Neumann architecture. I'm not covering that today. What I want to do is just show you the basic concept of how the CPU would access a variable. So in this scenario, the variable has already been written to the RAM, so it's already been assigned, it's already stored in here somewhere. So how would the CPU go about accessing that? So the CPU might request location 1, and you might be looking at that thinking, well, you just said a minute ago that the variable name was speed. Well, yes it is, but variable names were created and are used to make the programmer's life easier, because it's easier to talk about a variable called speed than talk about locations, because the speed has, the name is common sense, isn't it? It's easier to understand. So the CPU would know that the variable speed may be stored in location 1, for example. So what's going to happen here is the CPU is going to start a fetch process, and it's going to request down the address bus the data, okay, the variable data that is stored in location 1. And what it's going to do, when it arrives at the RAM will locate that data, which is here. So you can see inside of location 1 there is the value 5 that was already assigned. So what we're going to do is we are now going to complete the fetch process by popping that onto the data bus and send that back to the CPU. Okay. Notice that the CPU, when connecting to the data bus, it has arrows both ways. This is because it's bidirectional, which means the RAM can send data and instructions to the CPU, and the CPU can send data and instructions back to the RAM. So for example, at a later date, if we decide to overwrite this number 5, we could send a new value back and overwrite location 1. Okay. So, we've now completed the fetch process because it's arrived here at the CPU. The CPU can now begin the decoding of that and then move on to the executing, so it can use that value in some way to continue the program. Okay? So, let's take a slightly more in-depth look at it. So, inside of RAM theoretically looks like this inside. It's lots of little locations. And inside of these you might find data or instructions. Okay? And the data could potentially be one of our variables. Okay, so that's an overview of how it works. Let's move forward and have a look at the next stage then. Let's take a look at some example variables using Python. Here I have a variable called score and I assign it the value 5. When I print this out, you will see that score is printed to the screen. Now let's take score and reassign it with a new value. I've got score, I take the original value of 5 and I add 2 to it. So score now becomes 7. The program now shows that score is reassigned. It starts as 5 and then it becomes 7. The variable has changed. Let's do it again. score equals 10. Let's print out the score again. You will now see the score moves from 5 to 7 to 10. Let's look at a slightly more advanced example, and not particularly difficult to understand. I take x, I make x equal to 0. While x is less than 10, I'm going to print x out. But I'm going to take x and I'm going to increment it by 1 each time it goes around the loop. This means the value of x is going to be reassigned 10 times. As you can see, the values change from 0 through to 9. Okay then, let's take a look at a constant. A constant is a value that stays the same every time the program is executed. The constant is a fixed value in the source code, which means, like it says above, it's never going to change. So looking at our road example, if you think about the road that you live on, it has a static sign. It's not digital, it can't change. So the road that you live on, cars are expected to stay at 30 miles an hour. Okay, so that sign never changes. Someone can't go in and change it. It literally stays the same. So let's have a look at how that varies from a variable. Let's look at an example of a constant in Python. I create a variable called pi and I set it to 3.142. I then make another variable called radius and I set it to 2. I then print out the calculation of pi times radius squared, but I write it as print pi times radius, which is the same. Notice that pi's value is set to 3.142 and radius is set to 2, and these don't change after being assigned. This makes them a constant in Python, giving the answer of 12.568. I just want to point out that Python does not natively support constants. In other programming languages there is a way to physically set them as constants, so once assigned a value they cannot be overwritten. This is not the case in Python, so therefore in Python anything that is assigned a value and then does not get reassigned another value at a later date, we class it as a constant, hence the reason pi and radius are both seen as constants here. Some programmers like to take the values that are constants in Python and make them capitals. I've demonstrated this here on the word pi, so this would indicate it's a constant. You can see I haven't done this on radius. There is no expectation to do this, it's just a good programming practice to follow. Obviously, if I was following this programming practice, I would make sure that all of my constants are capitals, otherwise I wouldn't do it to either of them. Okay, let's do a comparison of constants and variables. So this one here on the left hand side and this one on the left hand side, those are both the variables. And this one here on the right hand side is the constants. So how can we see the difference between the two? If you look at the variable one here, you can see how it was originally assigned the value x equals 0. When it goes through the loop, the x look has an equals again and it's given a new value because it takes the 0, it adds 1 to it so it becomes 1. And it will loop round and basically this will be reassigned a value multiple times. Okay, so it originally started out as 0 and it will go through and it will be assigned 1 all the way up to 9. Okay, if we take a look at this one, look, here score was set the value of 5. And yes, we did print it out, but then score is rewritten, it's reassigned. It takes the original value of 5 and it adds 2 to it to give us 7. And then again here I overwrite it again to make it 10. So you can see the difference between variables and constants are the variables are letting me overwrite the values multiple times, or once or twice, depending on how many times I want to do it. So this one, look, I do it multiple times in a loop, and this one I overwrite it once here and I overwrite a second time here. Okay, it depends on the program. If we look at the constant example here, look, pi is set to 3.142 and radius is set to 2. And they don't change. Once that's set and once that's set, yes, I print them out and I use them in maths, but the pi value physically stays as that and the radius value stays as that. So here, if I was to print out pi, it would print out 3.142 because it's the same value, it hasn't been overwritten, it stayed the same. If I was to print out radius, it would print out 2. Okay? Remember that Python doesn't natively support constants. So, although we're treating them as constants, okay, effectively they could be overwritten. So you just have to use common practice there and not overwrite them if you intend for them to stay the same. In other languages, there is a way of setting them so you physically can't overwrite them. Moving forward. So, you might relate this to maths. In maths, you may have seen an equation like this before. And let's see how variables and constants apply in a maths equation then. What a lot of people don't realise when doing computer science is that when you're putting brackets in and you're basically doing coordinates and things like that, you're actually applying quite a lot of maths, particularly algebra, and you use either BIDMAS or BODMAS depending on which your school learn. So if we look at these, look, in this equation here, look, if I was given this equation, well, 6 is a constant and 4 is a constant because I need those to work out the answer. Now x is a variable. Now you're probably thinking, well, no, it's not a variable because once you've got the answer, okay, however, not everyone's going to get this right. So somebody might say that the answer was 1, somebody might say it was 3, okay, somebody might say the answer is 2.5, which is obviously the answer, okay. So it's a variable because the answer can change depending on who's working it out, okay. So constants, look, in this equation here, they stay the same, and the variable when you're doing your work it may change, okay. Now, I hope that helps. Thank you for watching. If you've got any questions, please feel free to contact me on this channel.